Hello, my name is Anastasios Magirias. I live in Athens, and today we'll see an informal introduction of Ghidra, the SRE tool of NSA. So we'll start from the beginning, downloading the Ghidra tool. So if you Google on Ghidra, it will bring you to on their website. In which place you can actually download here the Ghidra tool. It may take some time to download, so we can go and look on installation instructions. But before going to the installation instructions, I want to say some things about Ghidra. So up until the March of 2019, there was mainly only one tool that was professional, which was IDA Pro, and in order to buy IDA Pro you needed like 3,000 euros and then another 2 or 3,000 per decompiler that you would choose for each architecture. So you may end up paying 15,000 euros for a license per year. And when Ghidra came out on March 2019, it was a big deal, because now you could get most of the tools and whatever it's offered on IDA Pro, but on an open source tool. In order to get the sources, you can go to their GitHub page, which is this one, and it's under active development. So you can find the installation guide here. So in order to make it work, I'm using Linux, so I will I'm using Linux, so I have installed the OpenJDK because it runs on Java, and if you use Windows, you need also the JDK platform. It specifies actually which supported versions. So if you use Java 11 or higher than that, it's fine. I'm running Java OpenJDK 14, so then that's the default. I think it's a stable version nowadays. So if you have installed Java, that's all you need to run Ghidra. And then there are some other minimum requirements, like 4 GB of RAM and the storage for the installation. So as long as you have downloaded the zip file that they offer, then you unzip it and navigate through the command line to the place where you unzipped it. And now all you need to do is run Ghidra run or Ghidra run.bat on Windows to start it. The user agreement is here, and it opens the actual window and also the Ghidra help at the first time you open Ghidra. So Ghidra help is provides so much information that is too much to ask for. in a way where if you're searching for some terms or tools of Ghidra in here, you will find enough information. We will come back on this after a while. So this is the default menu that it offers. You can create projects, open projects, restore archived projects, and other stuff. The options that are you can find the options at the edit button and tool options. It has an Eclipse plugin in order to develop scripts for Ghidra, where here you specify the appropriate paths of the workspace and the installation directory, the ports that it used to communicate with Ghidra, etc. Here are the key bindings, like because there are some hotkeys that are offered for specific actions. This is the recovery page, where it takes some sort of snapshots, and this is about the menu, where you can change the actual theme of Ghidra to metal, other stuff like GDK, and so we won't deal with this. I'm actually only using this because for the Eclipse integration, running plugins and other type of stuff here. Later on we'll see it supports some you can write your own processor, where technically you lift the bytecode to assembly, and then from assembly to decompile the actual code, and have some sort of C-like language presented. So Ghidra offers a plugin also for that, for an editor where you write all these processors. But that's mainly what's happening here. We're going to create a new project. Ghidra offers two types of projects: the shared projects and the non-shared projects. The non-shared projects is when you work by yourself on something, and the shared projects is when you work alongside other people. Like if you contribute information to this project from if different people contribute information to this project. We'll work with the non-shared projects at first. Then you specify the project directory where all your projects will be saved. We will give it a name like test, and that's it. Now here you actually import files, because all the files you want to analyze, like firmware, DLLs, shared objects, executables. It supports a variety of processors, where you can see here. So all these architectures are supported currently. There's work being done to add more. I think the latest version, 9.2, added the V8050, which is for the automotives. So there are two tools that you can open your files with: the code browser, that's the one we'll be using, and the version tracking one, in which is used for if you have analyzed the file in the past, and there's a new version that is released, you can actually compare and transfer all your work from the old file to the new update. It does some sort of binary diffing, and the code browser, which is the main window that we will deal with. shortly. So let's import some files. I will import the ls binary, which lists contents on command line, but you can import anything. So after you select the file, you are presented with some information here, and here is the format. It actually identifies that the ls binary is an elf file format binary. Also, you can import with the raw binary. So there are some Ghidra actually has the potential to identify the file format every time you load something. If it's recognized, it will be identified by Ghidra. And this is all the supported formats, like Mac OS X, the PE file format, the portable executable, Dalvik, and other hex, Intel hex, Motorola hex, wholesale DOS, other file formats where they are supported here. The next one is the language, which is Ghidra has also identified that this is an x86-64 binary. It's Little Endian and it's compiled by GCC. So inside Ghidra there are some language specification files where all these happens, where you actually write some sort of their own language called Slay, and transform the bytes to lift the bytes to assembly and then to C. So for this, it has to be done for every architecture, and this language here is technically like a collection of values that are, for example, instead of GCC you can have Visual Studio here, or Borland and other compilers, but Ghidra identifies it also for you. So here, for example, you can use the CLang compiler or the Visual Studio compiler, and the description of the compiler that we have is this. You can find it here. You can actually see the complete, all the different options that you have here. So the first column is the processor, the variant of the processor, the size, which is the register size, if it's big or little endian, and the compiler that it used. So all these architectures that we saw, the supported processors that we saw, they are all here with their options. Also, you this is the destination folder, which is your project, and the project name, the program name, where you can rename it or give it your own name if you want. And also there are some options here where you can load it in a different base, or this is for more advanced use. So you click OK, and then it takes some time to load. There's this summary that is presented to you that gives some information about the binary, like the last modified time, the language that's used, the information about the addresses, the symbols. And here you can see on the lower side, at the additional information, you can actually see any problems that it had, like for example, ls is linked with libc, but we didn't specify libc, so where it can actually find this library. And also that we have 109 external symbols that are unresolved because we didn't load any libraries that the ls binary needs. So after you load the file, you can actually use a batch import, which you can import more than one file at the same time instead of importing them one by one. So if you double click now on the ls binary, the code browser will appear. And you are asked if you want to analyze the binary or not, because it says that it's not analyzed. So if you click no, nothing will happen. Like the binary will be just plain raw bytes, except for the headers that are identified as because of the ELF format, but no instructions will be disassembled, or you won't have actual information on your decompiler. So if you click yes here, you're presented with this menu, and here you can see all the analyzers that are checked by default. And if you click on everyone, you can see like a short description. All these analyzers will run on the binary. So for example, this one, the function ID, is responsible for finding known functions inside the binary that the compiler inserts. This is for locating and annotating exception handling information installed by the GC compiler. This is to discover non-returning functions and other stuff that you can actually tweak them. Yeah, this is searches for ASCII strings. So all this information that these analyzers will produce, we will see all that. So if you click analyze, it takes some time here. You can see on the lower right that it's working right now, and you can actually cancel it if you want. So after it's done, after some time that takes for the analyzers to run, now you can actually work on that. So it presents you there are technically several windows here. So there are like 1, 2, 3, 4, 5, 6 windows by default. So we can go through each one to see what information it has. So the program trees here up on top has all the sections that it discovered. And if you double click, it will isolate this section and it will present you only this section. So for example, if I double click it, now all I have here is only this data rel raw section. This is to if you go somewhere else, it will depict here in which section you are. For example, if I click here, now I am in init section, .init section, so it will follow you around. So this symbol tree window, it is here you can see all the imports that are imported from ls. So here you can see the libc, libbcap, and the external imports that it has. Um, so it actually calls all these functions. So the exports one is what is exported. Will work with the entry, which is the entry point to your binary. These are the functions that are executed on initialization before the entry and after the entry, and yeah, when you're about to terminate the process. So the next one is the functions, which lists all the functions that have been identified. So if you click on one of them, you will get transferred to the function. The next one is the labels that Ghidra identified. The classes, which we have none, and the namespaces, which is switch statements. Yeah. The window at the center is actually the listing view, where you can actually see the addresses. Next to the addresses are the bytes, and then it's the assembly instruction. So here it's like 3 bytes, and these 3 bytes have been identified as this assembly instruction. Also, you can see the functions and the function names. For example, this is this function was given a name out of its address, because this is the 10.5c70 address. That's why I took this name. So here you technically navigate through the code. Also, on the right, it's the decompiler view, on which wherever you click on the listing view, which is this one, the decompiler view will transfer you there. So for example, if I click on this if I click on this label, this is highlighted, and then if I move downwards, the decompiler follows me. And it's also the opposite. Like if I click here, it brings me to, it highlights the specific instruction. So they are technically connected according to your cursor. According to where you click. The lower one is the console, so it's for the scripting. We don't have time now to deal with this window, because you can see here the output of your scripts. And the last one is this, which is the type manager window, and here you can see all the defined data types. So it has some built-in types, which is like variable types, like sort or uint, and also has some type specific to the file that are imported by default because it's an ELF binary. And then these are all the Linux defined types, and here are the Windows ones. So according to your to what file you're importing, it loads the appropriate. These are called file archives for your binary. So Ghidra offers a variety of tools and windows, so you can actually see you can actually open you can view the defined strings. If you click window defined strings, this window will come up where you can actually see all the defined strings, their location, the string value, in which section they reside, and their representation, and also their type. You can play around with these columns, like you can right click and add or remove columns, so you can add other columns to this, in which function name it is, or the symbol type, the actual bytes of this string. So, and if you click actually on any string, it will bring you on the listing view to the place where it lives. So it is at this address here. This string resides, and you can see also like what bytes it occupies, and here's the representation. Also, you can see the functions that are identified. Here you can see that Ghidra found 415 items, which are functions. Some of them have names like fun underscore and an address, which are functions that haven't been identified as non-functions from Ghidra, and the compiler, during the compilation process, it gets rid of the function names for the functions that the program uses, that are defined in the program. So that's why these are probably functions that are defined from that are implemented into the ls binary, and we don't have their names, so Ghidra just appends the address here. But also you can see functions that have been identified by Ghidra. So this one is actually an external function which Ghidra identified. This is identified by hashing it, so it knows the name of the function. And you can also see actually other functions that have been identified. The entry point function have been identified, but the bulk of the functions are not. So mainly you will be dealing with these functions that are not they implemented by the ls code functions. So if you also click here on a function, you will be automatically transferred, and the decompiler will present you here the function, and also you will be transferred to the same function in the listing. So they are synced also. Also, you have the bytes view, where you wherever you click on the listing view, the bytes view will transfer you there. So here you can actually edit the bytes. For example, there's this button up here where you can click and enable editing, and now here you can actually let me see. Oh, because there's a defined instruction doesn't allow me to edit it, so I can go back here and actually tell Ghidra to clear the code bytes, and now there's nothing defined over here, so I can actually go back and edit that. So you can see the actual edits on the listing view. So when you're done, you click it again and then you're ready to go. We have the console, the checksum generator, which is where you can actually compute checksums for different highlight. Like you highlight an area here, and then you go back and you compute the MD5 sum of this area or other types of hashes, and then you change it, and then they also change. So it's a quick tool to compute some checksums and CRCs. Then we talked about the console. The bookmarks is a window where you actually can see all the problems that it encountered and other types of comments that Ghidra inserted. For example, here we have an unhandled elf relocation. It tells you which other stables were identified, non-returning functions. For example, abort never returns. If you call abort on a binary, then there's no point of analyzing what's after abort, because it never returns. So this is with the bookmarks. Here you can actually see your comments also. These are the comments. So these are all comments inserted by Ghidra on several like function names and other types of stuff, but you can actually define your own comments. Like if you go here somewhere on the listing and you can actually set a new comment on which you have 5 different categories of comments. This is the end of line, the pre-comment, the post, the plate, and the repeatable comment. For example, you can write something here and apply, and now you can see the comment on the listing view. or you can add a different type of comment, like the all comment or the plate one. And now it looks differently. So this is with the comments, the decompile window. Here you can actually, the disassembly view offers you disassemble the few instructions that are, if you click somewhere on the with your cursor, you can actually see these bytes disassembled. Like if I click here, it goes and disassembles these bytes and then continues for 5 instructions. Or if I click here, or here, actually these 4 instructions are the same as these ones. So technically you can, the purpose of this is to, if you are trying to pass instructions, you can see here the actual code, or before defining that this place is a place where instructions are called, you can look. I can technically do it even on strings, like this one, but this is a defined string. I can click here and it identifies it as a string, and then it actually moves forward and identifies, tries to lift these bytes into the actual assembly instructions. So here you can see that how these bytes are identified as instructions. This with the disassembly view. The equates table is a type of, let me see. No. Well, I don't know. I haven't used this so far, so. You have the function call trees, which is this window. It opens here. Oh, by the way, with the windows you can actually move them around. Like you drag it and then you move it here, for example, and then it gets here. So now I have the function call trees here, or I wanted to put it on the left and I place it this way here, or I want to put it back again, so it's here. So you can move stuff around and even undock them outside of Ghidra. So here I can click on a function, let's say the entry function. So here on the left side of the function call trees, you can see the incoming calls, and on the right side you can see the outgoing calls. So it says that Ghidra is not called from anywhere. The entry is not called from anywhere, but it calls these 4 functions. It points to these functions actually. You can open these functions and then see what's underneath them. Like this function calls all these functions, and have some sort of tree where you can see where a function call leads to different several other functions, which functions are called if this function is called, and etc. This is useful because you may be somewhere, let's say So in order to navigate between functions, let's say you click here on the symbol tree, you are presented here with the listing of the function, and here the disassembly on the right. So the entry function calls the libc start main, which actually calls the actual main function, which is the first argument here. So now if you double click on this function, you will be transferred both on the listing view and the decompiled view on this function. So let's say you click on some other functions too, and let's say you're here, you can actually see if this is a function of interest to you. You can see how you can reach this function. So here you see that this function actually comes from a call from this function, which comes from a call from the entry function. And also you can see what functions does this function call. You can have a function graph of a function. Let's say you want to see this function graph here. You can either click on this button up here, the display function graph, or you can go to Windows and function graph. So this is the actual function on a graph view. And now if we click on the main function, not this one, but this. Here, this is the first parameter, so it takes a little time to present it. So this is our function, the main function of ls. Here you can zoom in with Control plus or by the menu, and you can see all the code blocks and how this function looks on the graph view. And if you zoom more here, you can actually see the assembly instructions of. And then you navigate around here. If the listing view is not, if you don't like the listing view, maybe you like this more. You can take screenshots here. Yeah, you can go to the function entry point. There's a small you can actually edit how the arrows look, and if you double click on an arrow, what happens? You can edit all that. Or if you click on one, then there are some arrows that are in dotted lines, and so all of them are configured here. And also you can actually see what information is presented in the code blocks by clicking on this button with the white blocks and the brown one. So it's called edit code layout, and here you can actually disable by right clicking on a field here, and you can add fields or disable fields. So here I see only the opcodes, but not the actual um, operands, and you can, it's pretty much configurable, so you can tune it to your needs. Anytime, anywhere, you can actually hit the F1 button and it will bring you to the actual help page. So if you hit F1 while you're focused, while your cursor is on the listing view, the help window will come up and it will bring you the listing view information. So you can read here. There's plenty of information about customizing the listing view and other types of stuff. There's also like information about the compiler. So if you don't know what is something about, like the console script, the console window, you can use the help menu and the help will bring you here. The F1 button, I'm sorry, and the F1 will bring you here. Or the data type manager, all these, there's enough information here for all the windows that you will deal with and the tools. So let's say you have navigated somewhere around here. These two buttons up here, the left and the right button, is to move you around the locations. So if you click the left one, it will bring you to the last visited location. So now I go backwards to where I was, and here there's a small arrow up here where you can actually see which places you can go back in. If you want to check something or if you don't remember something, you can actually go back to where you were using these arrows, and then you can go forward with the right one. All on the window menu, there are some tools that you can use, or windows. Some of them are here on this taskbar. You can see the memory map. There's a memory map window where you can actually see all the segment information, and if they're read, write, execute, permissions, comments, and other stuff. You can actually create your own memory blocks here, but we won't do it right now. It's mainly used for file formats that are not supported. Also, you can see here the register map. This information comes from the specifications, where you can see the registers and what registers are available in this architecture, and yeah, mainly this. Ghidra offers, if you want to automate some stuff, you can actually use the scripting, the Ghidra API that is offered. Ghidra has by default some 240 something scripts, where you can actually, if you click on yeah, if you go to window and then the script manager, it will bring you the script manager, and here you can see all the scripts that are by default installed into Ghidra. And if you click on one of them, you will see some information like the description, the author, and other, like the key bind that the script is bind. And you can actually edit this script using either the Eclipse IDE or the basic editor. So because we haven't connected the Ghidra with the Eclipse right now, I'll use the edit basic script. And here you see the actual Java code that this script contains. And there are scripts for several types of stuff here that probably are useful. I have used some of them, not most of them. And you can create your own scripts here. Yeah, you can if you click on the help button on the up right, Ghidra will bring you to the scripting information that is available. So it has an API that is exported, where you can actually which one you can actually use for several types of stuff. So here, yeah, you can write your own scripts if you want, or run them. And also you can use the Python API, which is actually it is Python, so you run Python inside the Java, so it's like a Python interpreter implemented in Java. So if Java is 1 time slow, then this will be 10 times slower. But most people know Python, so I guess it can be useful. Yeah, the scripting API. Actually, I have used the IDA Pro's scripting API, which is on Python, and every time there will be a new update, it will be, my script won't work because they kept changing the API in every version. I think after 2019, when Ghidra came out, they fixed that, and now that it's more stable. But I had to write every script in every version of IDA Pro. And actually here you can see that yeah, it has some information about that, about yeah, the running a script and writing a script. So it exports this Ghidra script API and the flat program API. The flat program API is the one that doesn't change. So here, if you go to the class flat program API, you can see that no method should ever be removed from this class, and no method signature should ever be changed in this class. So this API, the flat program API, is maintained. So if you use it, you can rest assured that your scripts will be portable in the next version. There's also the symbol table where all the symbols that are identified are listed, like function names and strings identified also. And yeah, I think that's pretty much what it with the tools. Navigating is pretty fine here. So in order to configure all these tools and the windows, you can click on the edit button and the tool options and go to these. Here you're presented with some information about the function graph, colors, and the graph view, the listing fields, which are the most important, like how you want them to appear, or several different information, which you can actually again get help by pressing the F1 button, and it brings you to here on the operand fields that I was, all the options that you have and what every option does. So there's a lot of options. The decompiler, the colors of the constants of the variables. If you want the comments displayed, there are a lot of options here. For example, by default, Ghidra has on the listing display, on the listing fields. If you go to the operand field, you can. I think these two were checked. The markup inferred variable references and the markup register variable references. So if you apply them, it loads. Let me see. I don't remember, but it should have been around here. Okay. I don't know. So it was related to how the information is presented here, because sometimes where is it? Here Ghidra identifies a local variable which is on the stack as local 40, and you don't see the actual value of local 40. So in order to see that, you have to go all the way up, and here before the actual code, all these information about the variables, the local variables, is presented. So here you can actually see that it is minus 0x40, and it is identified as an 8-byte size 8-byte sized variable. So yeah, sometimes you want this, and sometimes you don't, because it may be annoying. Depends. Also, Ghidra, I think by default has the parameters that are passed, like the first and the second parameter, used instead of the register. So instead of the RDI here in this case, which is the first parameter, it uses the param_1 text. So sometimes you don't want this. So yeah, there is an option here on the tool options, but I don't remember where was it. I think this is enough for today. Maybe you have any questions? Do you? I don't see any questions, so I think I can stop here. Oh, another interesting option that exists is on the you can actually renaming is let me talk about this option, then I'll tell you about renaming. It is, if you go to the options, listing fields, and then cursor text highlight, this mouse button to activate is probably the middle button. So I put it on the left button because now when I click on the register or on a variable here, it highlights wherever else the same register is used. For example, here I clicked on the RSP register here, and then this field is highlighted. And if I click on the compare instruction, all the compares will be yellow. Or the move instruction, here you can see everything is. So it is kind of helpful because I want to quickly see where else this variable is used. So I put it on the left click, so anytime I click on somewhere, it's highlighted. So for example, on the decompiler view, you can click on variables, and then all these variables will be highlighted too, with the same variable wherever it's used. Renaming, yes, you can actually right click on the function first of all, and click and edit function signature, where you can rename it. You can say that this is the test function. Here you can edit the complete, like whatever it returns. If you think Ghidra is not good on identifying the right return type, you can actually edit it, or how the variables and which variables are passed. And if you click OK here, the function, here you can see it is renamed. The hotkey for this is the L button. So if you click somewhere and click L, you can rename a local variable or even a global variable and give it whatever name, and then you will see it on the listing and in the decompiler view. So I think that was it. I want to thank Tilda Center for hosting me, and I hope to see you soon. Bye.